Wait, so like what they say?
They just explained. Hold on. So we already saw the answers to 7 and 8. Did we get them or not really? Seems like from the homework, most of you got it. I want to do at least one of the two. Yeah.
Number 8 makes no sense.
Okay, let's do number 8 then. All right, so first thing I would recommend is that you have another sheet of paper because there's just not enough room. Some of you did it though, and it was legible, so I commend you for your tiny writing. Okay, so here is number 8. I am supposed to write the equation of the quadratic that passes through these 3 points. I don't know if any of these are the vertex. I don't know anything. So here's what we do. We take our general formula. There's just a quadratic in standard form, right? And then we're going to take the 3 points that they gave us. -4, -4. Take your time and make sure that you don't copy it down wrong. Because if you imagine how annoyed you'd be. So I always double check that I didn't drop a negative, that I have everything right. And I'm like, okay, cool, I got it right. So now I don't really need this paper at all. So if you remember, we are going to take these 3 points and all of these have an X and then a Y. And I'm just going to take the X and Y and plug it into the formula. All right, so there will be an A, B, and a C left in there, but that's okay. So for the first one, Y is -4 equals A times now X squared. X is -4. So I'm going to be squaring -4. Right, so it should be in parentheses. Plus B times X again is another -4 plus C. And then we talked about cleaning up that equation, right? So if you write it, if you actually do the squaring out and you sort of simplify it, -4 squared should be a +16. So I would write this as 16A, not A times 16. So we just swap those around. Same thing's happening here. I wouldn't write it like that. I'd normally write it as a -4B. And then I have a plus C on the end. So there's me rewriting and simplifying this. And then I do the same thing with the next 2 points. So this one, Y is -40. A times -2 squared plus B times -2 plus C. Clean it up. -40. That's now a +4A minus 2B plus C. And then the last one. Clean it up. And we are looking at 5 equals, that's now a +25A minus 5B plus C. So if you take a look at your work for number 8, you had to have had those 3 equations. So double check that you have them. They look like that. The signs are like that. I'll give you just a helpful thing for you to be checking as you're going. Whatever your A term is, like these should always be positive, no matter what, because I'm always doing whatever X is squared, and any number squared is a positive. So these 3 numbers right here, the coefficients of A, should always be positives. So should C, right? Because it's just a plus C on the end. And this is just going to depend on if your X is positive or negative. Okay, but the A's should always be positive. All right, so now we're here. Is everybody okay so far? We have these 3. Now you are doing exactly what we did in the last chapter when we said, hey, here's a system with 3 variables, solve this system. Okay, so now it's no different. This was literally the only new piece, was you writing the equations. But now that you have them, so let's see. Step 1 is to eliminate one of the variables. We talked yesterday about we might as well always do the C, right? Because it's already ready to go. Almost. So I'm going to take my first equation as it is. And then I'll take my second and I'll times it by a -1. Doing that is going to cancel out the C's. So let me just get them all in here. So I'll recopy the first one as it is. -4, 16a minus 4b plus c. Now I'm going to do the second equation all times a -1. So now it's positive 40 minus 4a plus 2b minus c. See why we do that? Because now those c's are going to cancel. And then if I add the others, I should get 36, 12a minus 2b. I star this equation once I get it, because I need to leave it alone for a minute and then come back to it. So I just don't want to get lost. Now that I've done it one time, I basically just have to do that same thing another time. But I have to use the one equation that I haven't used yet. So that means I'm going to have to use my third equation. Yes. Bless you. So I'm going to use my third, and then again, I'll do the second equation times the -1. It worked so nicely the last time. Let's do it again. So the third one, I copy it exactly as it is. Now I'm going to take that second equation and multiply it by a -1. So it's now positive 40, -4a plus 2b minus c. Whatever variable you canceled the first time, I have to cancel again the second time. So these are nice because it's always going to be really easy to do it with the c's. So I just always do it with the c's. Add it together. So that's now 45, 21a minus 3b. That's my second starting equation. You can leave them like this, your two start equations, and now you're down to a 2 variable system and you're just going to solve that. Yeah.
Is this all the tests? Is like the next test?
This is one problem on the test. Just, yes. I'm not going to give you 10 problems like this. They take too long.
Can we get, if we get like partial credit for like, if we took, like some stuff, right?
Yeah. What else is on the test?
When
The
is
entire unit.
Wait, when is
Oh,
it?
it's a unit test?
Yeah.
Wait,
That's what
what
tests
else was
are.
it?
That's a test.
Ah,
Oh, because I got this stuff down. That's all I was wondering.
Good.
That's what I
Well,
was wondering.
everything, like, think about the last, so it'll be factoring, solving by quadratic formula, completing the square, everything that was on the last quiz, plus all the stuff we've been doing, plus what we're doing today,
When is it?
Friday.
What?
Yeah, we're finishing today and
Wait,
then
let
we'll
me
review
calculate
for
to see
2
about
days.
this class.
Oh,
Oh, wait, no,
I
I'm
may
not
not
a
be here
doctor's
tomorrow.
appointment on that, so I won't be there.
Take it Monday if you want, or whenever.
How bad is your computer?
Pretty moderate, yeah.
I may not be here tomorrow.
iPad
Okay.
for confession.
All right, well, let's finish this problem, everybody. So now we're here. We're here. You can solve this like you normally would, but there's a better way. Hold on. Let's get the lighting right.
Right, yeah. That's what's happening.
And I didn't know it.
I swear I'm always fighting with the lighting.
Term
There we go. That's a little bit better.
Where am I?
Okay, everybody. So now you're here, right? You have these two start equations. Guys, we're not going to be ready for Friday if we're not paying any attention. Oh, dear. What we can do to make our lives easier is we can, if you notice this particular equation, couldn't I divide everything by 2?
just add
And over here, I can divide everything by 3. Actually, why don't I divide, I'm going to divide all of these by 2. And if I divide all of these by a -3, wouldn't that make it, that'll swap my b's. So I'd have a negative b there and then a positive b there. Ooh, save myself some time. So I'm just going to divide everything by 2. And that's going to get me 18, 6a minus b. Bless you. This is not a necessary step, but it is going to actually make my life a lot easier. Oh, I'm dividing by a -3. So -15, -7a plus b. Because now, look, these two are ready to cancel. I have a negative b and a positive b. So I'm glad that I did that because now I don't have to multiply anybody by anything. So let me just take that second equation. I'm just going to rewrite it under here so I can add them together. Negative 7a plus b. See how those b's cancel? Hooray! And now I'm just left with 3 equals negative a, which means that a is negative 3. That's sort of your first moment of truth. Your first variable should come out as a nice number, right? I told you there's not going to be any decimals, any fractions. So if that comes out as an integer, that's a good sign. And now I just have to find the second one. So I'm going to go back to one of I like to use the simplified start equations because they're just easier. So I'll just go right back over to this one. So I'll do negative 15 equals negative 7 times, now I know a is negative 3 plus b. Let's just figure out what b is. And we got a minus 21, and I get, what is that, negative 36? Right? Did I mess up? And then I just have one left to find, and that's C. So I already have A and B. So now I go all the way back to my originals, and I pick any one of these 3. So I'll do the bottom one, whatever. Doesn't matter. You pick whatever one you want. So I'll take that one, and I'm just going to plug in everything to find C. So 5 equals 25 times A is a negative 3 minus 5 times B, we just found out was a negative 36 plus C. I'm going to use my calculator to do some of the math for me. $180, and the negative 75 is 105. So just minus that 105 from both sides, and we will be in business. I get negative 100. Did you? Once I have my 3, my A, my B, and my C, which I do, remember that I'm just going to my general formula, and I just plug them in, A, B, and C. And there's my answer. So A is a negative 3, B was a negative 36, and C is a negative 100. Ta-da! Final answer. And everything came out nice. That's so refreshing when that happens. You can always double check. You can take any of your original 3 points, plug in the X value, and see if it spits out the Y value. If you were so lucky to get this as a multiple choice question, would you spend all this time doing this? I wouldn't.
No.
If they're gonna give me multiple choice, right? I'm gonna use that to my advantage. If they've given me 4 choices, they've given me 4 equations, and they're like, which one is the one that goes through these 3 points? Don't you think it'd be a lot faster to take a couple of the points and plug them into each of the 4? That'd be so much faster. So if there happened to be a question like this on your midterm,
Wait, when is the midterm?
day before spring break, or 2 days before spring break, you guys
Oh, yeah,
have to
that's right.
decide. But I wouldn't spend 15 minutes trying to figure out the problem. I would take the points and plug it in because I know it's got to be one of those 4 answers. So work smarter, not harder, my friends. Yes.
Isn't it gonna be like, well,
It's 50 multiple choice questions.
How much is it? Is it the same amount as I mean, does it count as much as the final, or is it like a little bit less?
Same.
It's like 10%, 10%.
Yep.
I see.
wait, is it only 50%?
50, 5-0.
Oh, 50 more choice?
2 points apiece.
Working. Can I
Go
go?
so fast.
I will. Can you move the dates up?
Okay, so any questions about last night's homework?
And,
We're all right? Okay, so if you look further down the worksheet, we actually didn't get this far to talk about switching between something like number 9 here. Switching between something in standard form and turning it into vertex form. It's actually easier than you think. So let me just remind you real quick. This, oh no. Oh no. I don't have, everybody's been stealing my, oh no. All right, I have one left, so. All right, so this ax squared plus bx plus c, that's standard form. We also have talked about vertex form. A times x minus h squared plus k. This is vertex form. So questions 9 and 10, oh, sorry, are asking us to switch between these two. So they're giving it to us in standard form and they want us to change it into vertex form. It's a lot easier than you think it is, because think of what I need to write something in vertex form. I need to know what A is. Don't you know what A is? Like if you look at number 9 and I ask you what A is, you know what it is, right? Tell me, what's A in number 9? -2, right? So it's still gonna be -2 when I convert it. So, okay, cool. I know what A is. Oh. That's my phone. All right, Sylvia. I have them both. Yes. Sure. No problem. Okay. Okay, so Elise and where'd you go? Oh, and Maddie. They want you in the tech office at the whenever we're done with this. I don't know why. I'm just the messenger. Okay. So we are converting from standard to vertex. We already said we know that A is 2. The only other thing that we need to know is the vertex. I need to know H and K. But don't you know how to find the vertex of this? Think about when we were graphing these. How did we find the vertex? Yes.
The opposite of B over 2.
Yes, -b over 2a. Remember that? And then you would take that answer and plug it in. So then all we have to do is find vertex H comma K by doing -b over 2a. All right, so let's do that. -b over 2a in this case. So let's sneak it over here. That would now be a +8 over -4. So H looks like it's going to be at -2 comma something, right? Do you remember how to find the something?
You plug the -2.
Right, I take -2 and I put that in for X back into the equation and just see what comes out. So we're going to do -2 times -2 squared minus 8 times the -2 minus 2. Lots of 2's in this. And now just make sure you evaluate the right way. So -2 squared is now +4 times the -2 is -8 plus 16 and a -2. So what's that? 8 minus 2 is 6. Did you get what I got? Yeah, okay. So now I know my vertex is at -2 comma 6. And now I have all the pieces. I have A, H, and K. So I can just pop them into the vertex formula. A was -2 times X minus a -2. So that turns into a plus. And then plus K. There it is. Did that make sense? You see how we did that? So go ahead and try 10. Same idea. You already know what A is, and then all you have to do is find the vertex. Plug the pieces in, and you're in business. Okay, so I'll give you a minute to try 10. The tech office called and said when we are done with what we're doing, that they want you and Betty to go to them in the office, at the
Me?
tech office, yeah.
Me and who?
Betty. I don't know why.
Tech office?
Yeah.
Okay, at least they didn't call it over the intercom.
True.
Oh,
I have no idea.
wait, why? When?
Well, it can't be that bad because if it's that bad, they're like, they don't care if you're in the middle of something. They're like, tell them to come right now. But they were like, she was just like, oh, when they're done.
Oh, okay.
So I have no idea. That's all I know. Okay. Did you try number 10? Did you guys get it? Jimmy, you have an answer?
Ready?
Yeah.
Was that what you were? I thought you were raising your hand to give me the answer. Or did you have a question?
I was gonna say that I need one more.
Oh, all right.
Oh.
Ooh, this is one of those ones that I bet some of you are gonna make that big mistake that I keep telling you not to make. So fingers crossed that you didn't make it. I guess we'll find out in a second. The big mistake comes from this right here. What did you say that was? That is -16. That is not +16, friends. I know you're like, but -4 squared is +16. That's not -4 squared. I know when you're reading left to right, it sure feels like it is. But this says when it's not written in parentheses, right? And look up here. This said, just go back to what this looks like. This is saying take whatever x is and square it, and then take the opposite. That's what that notation means.
Put my 4 parentheses.
You could put the 4 in parentheses if you want, if that helps you. Yeah, so that's fine. Just you can't insert, if you put parentheses around the -4, then you'll be plugging in -4. And that's not what we're plugging in. We're plugging in +4. So I have to do 4 squared is 16, take the opposite. That should be -16 right there. Plus 32 minus 15. So what's that? 16, isn't that just 1?
Yeah.
So I get 4,1 as my vertex. And now I have all the pieces I need. I just plug it into the formula. So what's it look like? Who wants to tell me? Y equals what? Go ahead, Sam.
Y equals -1 parentheses x minus 4 squared. Those parentheses. Or like the 2's outside, the square's outside.
Yep.
Or like this one.
+1.
Yeah.
So just like that?
Yeah.
Perfect. Double check that you got the same thing. Did you? Yeah? Okay, good. So I also made a bit of an executive decision yesterday because I was looking through, was looking at your midterm. And so there is a third form called intercept form, which is actually super useful, but it's not on your midterm. And I just didn't, I don't know. It's one of those things where like, if we had a ton of time, maybe I would go into it more. So maybe after spring break, I'll touch on it. But if it's not on the midterm, I was like, you know what, maybe because we don't have a ton of time. Not that it takes forever, but I just figured, let's hold off on that. Let's get through everything else that we really need to get through. And then we'll come back and touch on that if we need to. Okay, by the way, you know what's not on here, but let me just ask you this in general. What if I wanted to go the other way? What if I had something that was in vertex form and I wanted to go to standard form? So if I give you something like this, how about 2 times x plus 3 squared minus 5? Could you turn that into standard form? So it's already in vertex form. How would you go back the other way? It's easier than you think.
You already have your A.
You do. Anybody have a thought how I could make that look like just that? It is true that we already know A, so if it was multiple choice, I would just make sure, like, cross off anybody that doesn't have A as 2, right? So,
Would you do negative of B over 2A equals negative?
easier than that. Yeah,
But you might have put in C.
because that's, if you actually square this, you're gonna get a constant there too. It's gonna combine with that. So that's exactly what we do. You just multiply it out. So you don't even have to remember anything. You just have to like actually do the like simplify it. So take x plus 3, square it, times it by 2, and then do the minus 5. So now be careful though, because I know some of you are going to say, oh, x plus 3 squared, isn't that x squared plus 9? And I'm going to say, heck no. That's a binomial, you're squaring it, you gotta FOIL that thing. So you're really doing this, aren't you doing x plus 3 times another x plus 3, right? Isn't that really it? So you gotta FOIL that puppy together. Now where do you do the 2? Do you FOIL first and then times by 2? Do you multiply by the, it doesn't matter. Doesn't matter, because it's all multiplication, so it's up to you. If it's easier to, what you don't do is you don't distribute the 2 to this and to this, that would be wrong. Because then it's like you're multiplying 4. So here's what I usually do. I usually just FOIL them together, right? So, and I'm going to put my answer in parentheses, FOIL all that together. So it's x squared plus 3 plus another 3 would be a plus 6x and then a plus 9. And then I'm going to multiply everything by 2. You don't have to do it that way, but I don't know. Personal preference. And I don't mess it up that way. And then see how these are going to combine. So C is actually not going to be the negative 5. It'd be plus 13.
Wait, why is it 16?
Because I messed up. Did I mess up? It's supposed to be a 12. Thank you. Okay. Does that make sense?
Yeah.
Let me give you one more to try. So that's all you're going to do. You're going to FOIL out what's in the middle and then just simplify everything.
Wait, so what kind of question was asked? If like you're given that equation.
It'll say change to standard form or convert to standard form. Yeah, because this is vertex form, and then you want to make it look back like standard, which
What kind of form is that? Just like a random,
right here.
no, like what kind of form is like?
This one, that's
Yeah, like
vertex.
the one-
So if you're in vertex form and you want to get back to standard, you just multiply everything out. So let me give you one to try. So same instructions, change to standard form. Let's do, how about negative x minus 3 squared plus 7. Take that one and see what you make of it. So how did we do with this one, okay? Take that as a yes. You are welcome. Okay, so hopefully you came in here and you were like, oh, I have to do the x minus 3 times the x minus 3. I'm gonna FOIL that together. That's a great idea. So I like to FOIL it together and just put my answer in parentheses. I'll deal with that negative in a minute. So let me FOIL x squared minus 3 is a minus 6, and then a plus 9. And then I have a plus 7. Now I just need to distribute that negative throughout. So I have a negative x squared plus 6x minus 9, and then a plus 7. So you can see that the last thing is those constants are going to combine to give me a final answer of minus 2 on there, right? And then I like to just do a real quick double check. Hey, my a in the beginning was -1. A should still be -1. All right, that's a good sign. You could also super check yourself if you wanted. You could find the vertex of this thing. See, I know looking at the beginning, the vertex is at +3, 7, right? +3, 7. So I could do -b over 2a and see, does it get me out? +3, 7. So anywho, there's that. And the last thing we need to talk about with these quadratics, for now anyway, we're going to look at some word problems. They're easier than you think. Don't get nervous. So, one thing that I need to tell you about quadratics and parabolas, if you have something in free fall, so if you kick a rock off the mountain, if you throw your pencil, if you shoot a basketball, all of those things in free fall, I know you're not going to believe this, but it's true. They follow the path of a parabola. I know. That's so crazy. So you can actually model the path of some object in free fall. So cool. I mean, yes, there are other things, like if you're dropping supplies from an airplane, you got wind resistance and parachutes, all that kind of stuff goes into play. But if I'm just shooting a basketball, yes, there's some air resistance, but I mean, it's relatively negligible, right? So if you wad up a roll of paper and you try and throw it in the trash, that arc is a parabola. Yes! Isn't that so neat?
Don't put math in the sports.
Oh, it's there, my friend. It is there.
What is that?
Math in sports. Yeah.
Yeah,
Do not do that to me.
What if you throw a ball?
Yeah, because then I'm gonna start
The
reading.
sprinkler broke
And the
my
what?
parabola.
So like you have your
How do you
starting
say
point,
it?
you have the line, so it just goes down. Then there's no object.
That'd be a nice name.
So that's a great question.
Isn't that one of the
Think of
parent
what it
questions?
would have been.
Well, it would still be, it's still a piece of a parabola. You're just not getting to see the whole thing. Have you guys played Angry Birds?
Oh my gosh, my
Yeah,
dad
it's
still
awesome.
plays it from 2012.
It's all parabolas. It's all, if you take it and you, I don't know, you're familiar with it, right? Even if you didn't play it? You have the little bird on the slingshot and you let go and it literally follows the path of a parabola. It's insane, right?
Is the tiny glass that turns.
I just found my son plays with like my old flip phones and stuff from way back in the day. I found the charger to one of them. I'm like, this is not gonna turn on. It turned on.
Do your flip phone?
My flip phone still
Oh my gosh,
works.
do you still leave
I
your contacts?
yes, so I am living in my mid-2000s life now.
Oh my god.
There's only, I mean, it's so funny because you open it up and then I go right to the pictures and it says 80% memory full. There's like 37 pictures on it. And it was 80% full, but I'm like, oh my gosh, look at what I was doing. There's old text messages on there.
You know what's
What were
really
you
funny?
doing in the 2000s?
Probably a lot that I shouldn't have been.
You know what's funny?
What?
When you watch these videos and you go off like something that's not
Oh.
math, it's really funny to watch.
Well, I always,
I'm like, huh?
I wonder, because I'm like, maybe I shouldn't be posting this, but you know what, internet, you're getting the real
It's
deal
the
here.
authentic experience.
It's the authentic, these are
It
unedited.
puts you in like the student mode. It makes you feel like you're in the classroom.
That's
Well.
not always a good thing.
No, because then it's so
Fair
then it's not so
enough.
condensed in like math, and then like you get a little bit of break.
Yeah, I mean, it's a lot. These are long blocks. You need to break it up a
Yeah,
little bit.
for real. Wait, when did you graduate college?
What do you think?
2000.
Ooh, hit the nail on the head.
Really? That's when I was born.
That's when I was born.
Same here.
Look at you. You're so
Oh,
old.
I
I'm just
told you
kidding.
I was
I'm
old.
just kidding. I'm just kidding. My
No, your son's only 5 years old. You're not that old.
I didn't have them till, when was I think I was 33, 30.
that's what my mom was when she had my little brother. Besides, age doesn't matter.
I'm at the age where like when someone asks how old I am, I don't know. Like I have to count back. So it's all like, it all
Does that
is a
really
blur.
happen?
Oh, yeah. Oh,
my
yeah.
gosh, that's so crazy. Wait, so do you know how old you are? You don't have to say you don't want to.
I mean, I basically just told you, I think I'm 30, I'm 38. I'm gonna turn 39 this year.
I thought you
Right?
were like 33 tops.
Oh, well, thanks, but
I'm so bad with age.
My dad's
Like,
60.
Me too. Well,
Really?
my mom makes it so hard because she's
wow,
like,
my mother is about to turn 62.
and
My
she
mom's
knows-
only 61. That's so funny.
Well, my dad,
Like she has like
he didn't
abs. She
settle
has
down
like
until about
rock hard
2002.
biceps. Her
Because
mom's
right
the
after he
same.
finished college, he went to the service.
And she's
Um,
she's just like.
My mother was on the young side.
My dad actually still serves.
No, but like, I
Oh,
watch
wow.
little kids,
Good
I'm
for
like,
him.
you're 5? They're like, no, actually, I'm 7. I'm like, oh, sorry.
All right, so
So-
you ready to talk about word problems with parabolas?
There's no in between.
Oh, sorry.
No, there's this girl that's like 5 and she's like up to my shoulder. I'm like, bro, I
That
can't
was me.
spot you.
That was me.
I'm
I was
like-
such a tall child. Actually, no.
Okay, everybody, so let's take a look at what's going on with this one. So it tells us here, using the graph at the right, it shows the height in feet of a small rocket, t seconds after it is launched. The path of the rocket is given by the equation, blah, 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 right? So they're giving us the equation, that's cool. So I want you to imagine this. You have a small rocket, it's gonna blast off, it's gonna go up, 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 up. Looks like it's gonna reach its maximum height, and then it's gonna come back down. There we go. So if you look at this graph, you can answer a whole bunch of these questions pretty easily. How long is the rocket in the air? 8 seconds, right? If you take a look at the bottom. This is my time in seconds. So from launch, goes up, comes back down, and hits the ground, and we're at 8 seconds. Okay, easy peasy. Greatest height the rocket reaches. Yeah, it looks like, because each of these lines is 10, right? 10, 20, 30, 40, yep. So yeah, I'd say 260, right? Do we all agree? You see where that's coming from?
Yeah.
260? So 260, what is that, feet? Yes, feet. Now, how high is the rocket after 1 second?
I mean, 100. One, I had it.
Yeah,
Aw,
I'd actually go a little bit above. I might say 105, right? Because it's not hitting right there at the lattice point. So I'm gonna go about 105-ish. 2 seconds, how high is the rocket?
About 200.
Let's follow. So they have a dot there, but the dot doesn't really match up with the graph. Yeah, I mean, the dot really should be right there. Yeah, I'd go with 200. Is it going up or down? Up, it's still on its way up. 6 seconds, how high is the rocket? Yeah, I think that one's, yeah, 190-ish, it's looking. And are we going up or down? We are going down. Now, here's a good question. Do you think the rocket is traveling faster from 0 to 1 seconds or from 3 to 4 seconds?
1, 0 to 1.
I agree. Why do you say that?
It probably has the most, like, it's starting to slow down at 3 and 4.
Yeah.
It's like 1, it's like just.
Right, look from 0 to 1 second, how high it's gone. It's gone from 0 to over 110. So there's a change of about, or 105 or whatever we said. So it's going up 105 seconds in that 1 second. Now, if you look between the 3 and the 4, I've only gone up, what, 20 feet? So it has definitely slowed down. And if you can visualize, you know, throwing something up into the air. You ever shoot one of those bottle rockets where you like stamp on the thing and it goes up and comes back
Oh
down?
my God, I
Right?
got hit in
I did
the
that.
eye.
So it goes up, right? And then as it nears the top, it slows down, right? Because it's basically got to stop in midair and change direction. Because it goes from going up and then it's going to stop and then turn and come back down, right? So it makes sense that in the beginning, is we're going to be going very fast. We're going to slow down at the top because we're changing, we're losing momentum and we've got to change direction. So yes, 0 to 1 seconds. Now, they ask you number 7, using the equation, find the exact value of the height of the rocket at 2 seconds. So what did we guess? We guessed about 200, right? So what we can do is we can go to the equation that they gave us right here. H equals -16t squared plus 128t. And what do I do if I want to know how high it is at 2 seconds? Plug in 2 for t, right? So that should be easy enough. It'll be 2 squared plus 128 times 2. So grab my calculator and have it tell me these values. Yeah. Yeah. Sure. Yes. Yep.
Oh, look. I'm trying to do this. What was your favorite song from the 2000s? Like, what's a song that you feel like?
Sean Paul was very big. We love Sean Paul. Give me the light. Those kind of songs.
Is that, yeah.
Do you not know Sean Paul?
I do.
Oh my God. When did I get
didn't
so
wanna
old?
say that, but what are some songs by him?
Give me the light.
Sing it.
Oh, I can.
Take it away.
You know Sean Paul. Once you hear it, maybe I'll play at the end.
Yeah.
You know, once you hear it, you're like, oh yeah.
Okay.
That old person song. Anyway, that Missy Elliott, Rihanna was very big at the time.
Oh, my dad grew up in Montreal. Yeah, I pronounce it.
I don't know what
But
that
that's
is.
the upstate New York. I told him about how he lived next to the jail.
Oh,
He was like, oh, that's like where I grew up. Malone.
it's not ringing a bell, but
Yeah, the population was like 1,000.
oh. Okay, so I get 192 when I plugged all this in. Did you? Oops, sorry, a little bit off. Did you get 192 when you actually plugged in 2 into the equation? So we had estimated about 200, didn't we? So we were a little off, 192 feet in this case. All right, easy peasy so far. Let's try the next one. The next one's a little bit trickier because they didn't give us a graph, but that's okay. They gave us an equation. So it says a ball is thrown in the air. The path of the ball is represented by the equation, boom. Graph the equation over the interval 0 to 8 on the accompanying grid. All right, so what am I gonna need?
Wait, can you zoom in a little bit?
My numbers are there?
Yeah. No, like down a little on like the equation. Yeah, that's good. Thank you.
You're welcome. So if I'm gonna graph this quadratic down below, what is it that where do I even start with if I'm gonna graph a quadratic? I really start at the, what'd you say? The vertex, yeah. So let's take a look at, here's our equation. H equals negative t squared plus 8t. So I find my vertex like I always have, negative b over 2a. Let's just list a, b, and c real quick. What's a? Negative 1. What's b? And what's c? Z, yeah, c is 0 in this case. If that 8 didn't have the t on it, if it was just an 8, then it would have been c, right? And I wouldn't have had a b term. But in this case, I just don't have a c term. All right, so I need to do negative b over 2a. So that's going to get me negative 8 over negative 2. So I get a positive 4 comma something. Take a second and plug that 4 in and see what you get out.
We're into the like negative t.
Yep. Make sure you're being careful with those signs. And see if you get what I got. Did you? All right, so now let's see. So I kind of have to set up my grid here. They didn't give me a scale. So I know the highest I'm ever going to get to is 16. So does it make sense to have each of these be worth 1? 1, 2, 3, 4. Yeah, I think that'll fit nicely on the y-axis. And then the time, we know we need to go from 0 to 8 because that's what they told us to go in. So my corner is going to be 0. So maybe every other line like they did in the graph above. So I can plot my first point at 4. I know I need to be at 16. So that's going to put me right there. Draw my axis of symmetry to sort of help me. Oh, sorry. I want to work smarter, not harder. I don't want to graph all these extras. And so how do I graph it from here? Where should I go? Follow the pattern. Now, a is a negative 1. So instead of going 1, 3, 5, we're going to times all that by a negative 1. So I'm really going to go down 1, down 3, down 5. Now, you got to be careful, though, because we've changed our scale a little bit. On the y-axis, every line is one unit, right? But on the x-axis, that's not true. I went every other line. I don't know if you did too. Probably, right? Otherwise, you're going to have it so squished. So when I go down 1, on the y-axis, I'm literally only going down 1 because that's 1 unit. But when I go over 1 unit, puts me here, right? Over 1 second. So I want to go all the way over to this line and mirror it. Does that make sense, right? Why I'm doing it that way? Because on the x-axis, 1 second is actually 2 boxes, right? So I'm going down 1 on the y, and then 1 whole unit on the x would be 2 boxes in this case because of how we set it up. And then I'm going to go down from that point 3, 1, 2, 3. But again, over 1 whole box is this. And then mirror that over. And oh, I can probably fit the 5 this time, right? Usually I can't. even get the next one. Yeah. And look how nice. It lines up perfectly, right? Which makes sense because at 0, it's starting at the ground. Oh my gosh, what a beautiful parabola we just made. Huh? That's really nice. Now we can answer the questions that they asked us. What is the maximum height of the ball? 16. You could have answered that without even graphing it. You didn't need to graph it because think about it. Isn't the maximum going to happen at the vertex? You just got to be careful, right? Because like when I give you this question on a test, because I think I do. I don't even think I ask you to graph it. I'm going to just give you the equation. I'm going to say, okay, give me the maximum height of this ball. Some kids are going to answer 4. 4 is not the height of the ball. It's the 16. What is the 4? It's the time, right? It's the time when it reaches the maximum height. So I could ask you 2 different questions that both, their answer both comes from the vertex. So I could say, at what time does the ball reach its maximum height? That would be 4. And I could also say, what is the maximum height that the ball reaches? 16. Okay, so in this case, they wanted that 16 feet. And then see if you can answer the last one. How long is the ball above 7 meters? That's useful to look at your graph for. Jimmy, you have it?
6 seconds.
I agree. For 6 seconds, it will be above 7 meters. So if I look, here's 7 meters, right? So if I just sort of put my ruler, all of this time while the ball is in the air, it's above 7 meters. So that's happening from starting at second 1 to stopping at second 7. So between seconds 1 and 7, we're above 7 meters. That's a total of 6 seconds. Does that make sense where all that's coming from? Okay, is there back? Oh, there's a back. What luck. I had a whole nother sheet, but oh, this is, yeah. Oh, I'm so glad that this question is here. I'm gonna have you do this backside for homework.
Wait, so this was 6.
Yes, that was 6.
Okay.
Okay, so give this a shot. Tomorrow, we're gonna practice some more with word problems. Just because, you know, this 15 minutes isn't enough. So we'll do a little bit more practice. And then my plan is, so tomorrow's Wednesday. We'll review for the rest of the time tomorrow, once we're done with the word problem stuff. And then we'll review all day on Thursday. And then our test will be Friday. I am after school today, if anybody wants to stay. So yeah, all right, give this a shot. I will go open it up on Jupyter.
Do you want to do the whole back?
Yes. Oh, and Maddie and Elise, if you wanted to head down, that's probably a good time.
Oh, yeah.
Jimmy, give me 1 second. Let me just stop the video here.